Good morning, early morning mental masturbation. Here with me, we gathered together again. I have a meeting at 10, so yeah, I could make it, guys. I could make it. Finally, I could make it. I woke up at 7 a.m. today. So, my thesis. Let's see what we did last time. We considered, like we said, steady state uh, does not sound well. Why? Because the steady state solution was not good, didn't look good to us. We said, well, maybe the assumption that we have a steady state is wrong from the beginning. Let's assume that at every time step they are trying to optimize the utility like a myopic and optimize the utility for the next time step. And so you have it or you don't have it. Oh, guys, I forget. Like last couple of videos, my voice was not heard, so I have to speak louder, especially when we have the AC on, especially when you are showing some Andrew NG. So this is the analysis for steady state. And we have these situations where we say this. And then we said the steady assumption, state assumption sucks. What if that doesn't work? Then we want to see what happens every time update or like myopic. And then we had Expedia dataset, or we can get the real data. And here I put a note, stay focused, because I suggested 10 things to do, so one thing at a time. And we had some data sets on Kaggle. Exactly. Now we are on the time step. Case, which is S1T plus 1 is alpha S1T plus P1, exactly. And firm 1, firm 2, they have price, they have bidding, no, not bidding, buying sponsorship, and the previous score. Yeah. Then we have U1, which is the price times the odds that they sell their product minus what? Price is sponsorship. So at time t plus 1, this is the money he makes, and in this myopic behavior we assume that he wants to maximize this. And then we try to find the best response. If I had something like this, hold it like this for me, it was very good for my posture. So it's stupid because firms care about their score over the time. Anyways, we will do it. So it is not I agree. Like sometimes we do things that are not completely rational. Maybe somebody says, "Oh, they should have a whole plan for over the time to maximize." But still, there are points still. There are intuitions we can get from this myopic behavior. But to be honest, a good strategy should consider your score over the time. All right. What does it say? It says okay, so we have b2t plus 1 and p2t plus 1, and we wanna set p1t plus 1, p1t, and we have assumptions that p1t and p2t less than q1, q2. It says b1t plus 1 epsilon plus this. Where did we find this? This comes from the comparison, right? So if we set b1t plus 1 a bit above this ratio here, right, this ratio here, whose birthday? It is Sam's birthday. Give me a moment, guys. Let me clear my... Okay, better. So v1t plus 1 is this, and u1t plus 1 will be times p1 because you bought the sponsorship at the amount that makes you win the competition. You will be at the top of the list. So now your utility will be u1t plus 1, p1t plus 1, p1 minus mb1t plus 1, q1, and okay, that was one situation where your utility ends up being you want to make p1t plus 1 as big as possible, q1, and minus m b1t plus 1. You want to make b1t plus 1 as small as possible once you win, so you make this epsilon as small as you win. Or you want to have the other situation when you're losing the competition, but probably you don't pay for sponsorship, so it's still worth it. So you set b1t as 0, u1t plus 1 will be p1q. Then you set your price again as q1. There is no cost for sponsorship. Both situation, p1 will be q1, b1 will be, if your set will be, exactly, if you want your score be higher, you set the ratio plus epsilon, otherwise you set it as 0, And then u1 will be phi1q, both cases exactly. Okay, now we have firm 1's best response to firm 2. If we find best response of firm 2 to best response of firm 1, we found Nash, right? Let's assume firm 1 wins the ranking game, then so P1 is Q1, B1 is the maximum of this, U2 is this, and we set P2 as Q2, B2 as 0, completely makes sense. And B1 T plus 1 will be, what will be? Okay, now, yeah, in the ratio at the top of the page, B2 T plus 1 will be 0, so B1 T plus 1 will be this simpler term. And the assumption at the beginning still holds. And P1 T plus 1 Q1 P2 T plus 1 Q2 P1 T plus 1 is this, and this is this. So we already computed it. Maybe we want to code well, it is kind of close to the the equilibrium we found in the steady state. Just only thing that is changing is B2 all right. What is this final assumption? Q2 P1 minus P2. Where is this coming from? Okay, we should check this assumption. Okay. What is S1T plus 1 is alpha S1T, right? Well, we don't know that. What is it? Well, we don't have S1T. I don't like this because it is based on S1 t plus 1, while it should be S1 t exactly. Okay, this is the assumption, right? S1 t plus 1 greater than S2 t plus 1. And S1 t plus 1 is alpha S1 t okay, R1 t will be 0, right? What is R? R is Q minus P. So shit. So we want to decide on P1t and P2t. Fuck S1t plus 1. I don't know where did that came from. S1t and S2t are given to us as firms. We have to decide P1t, P2t, B1t, B2t, and that's it. Why did we do that? Doesn't matter, okay. Let's try to maximize P1t plus 1, all of the t plus 1s. Alright, and the same thing holds. So you need to check. Alright. These are right. These are all right. S1 t plus 1. Then we will have this. Now best response to best response. And we will have this. But the thing is, okay, this is not done yet because the assumption that from this. Okay. So your S1 t plus 1 and S2 t plus 1 does not depend on your P1 or P1, P2, B1, B2 t plus 1. They depend on at time t. Alright, so This is an equilibrium, alright? So your scores are already given. Perfect. And what is this assumption coming from? It's 1, 2 plus 1. Okay, this is just an assumption, okay? Doesn't depend on the equilibrium. But it is interesting to see what happens in the next time step. So let's assume what's happening here. Let's assume S1t plus 1 is greater than S2t plus 1. We can have two situations. Well, both of them set their price as the always prices are at the quality amount, and sponsorships in this case, the first case, will be both 0 and in this case first firm wins the ranking game. He sells with probability P1, firm 2 will lose, or firm 2 will buy some sponsorship in order to win the ranking game. Then U1 will sell with probability P2, and U2 will sell with probability this. But which one will happen? So in both cases, look, exact. In both cases, firm 1 is kind of inactive. He is not buying a sponsorship, and he's not buying a sponsorship, and and his price is set at the Q1, right? So the only thing that remains is the decision of firm 2 to buy a sponsorship, setting his or not, right? He is the only thing that is changing here. Look, this one, he can decide between these two. Other things are kind of fixed. Therefore, and he will buy a sponsorship if and only if his utility when he buys the sponsorship, which is P1 Q2 minus M epsilon, the sponsorship he bought, plus S1t plus 1 this, is greater than the utility he gets when he does not pay for sponsorship. So this inequality, if this happens, both data buyer 2, firm 2 will not buy sponsorship. Makes sense. Otherwise, he will buy sponsorship. Makes sense. Just let's compute. S1 t plus 2 alpha S1 t plus 1 plus, well, both of them, that's it. Both cases, both scenarios, R1t and R2t are 0. So we had the assumption that, by assumption, S1t plus 1 was greater than S2t plus 1. So at the next time step, it will be the same. 1. And okay. Okay. This is the memoryless situation. So even when he buys sponsorship, the ranking doesn't change. But in the memory, the one that has memory, like buying a sponsorship, goes to your history. I think ranking will switch. Help. Sponsorship does not help the ranking. Now kind of we can say B2 t plus 1 will be alpha b1 t plus 1, which gradually goes to 0 because alpha is less than 1. So in a sense, we are going to the steady state situation that we studied before. Where is it? And in a sense, everything goes back to your starting point. And what is it saying to us is that the ranking doesn't change over the time. Firms set their prices as high as possible. Buying a sponsorship helps you, but not much. It doesn't have a lasting effect. Even here, right, we have, well, what is R1? R1 is 0. So S1 and S2 should be 0, right? Yeah, because P1 is Q1, P2 is Q2. R is Q minus P. So actually myopic is converging to the steady state. So all of them, okay, we forgot to say that last time when we were computing steady state. Now maybe with memory one changes the game a bit and they switch roles, the ranking switches, and fuck. Okay, we can compute the memory. Alright. With memory. We have S1 t plus 1 equals alpha S1 t plus gamma B1 t plus P1 1 and they leave the rating, right? Again, R1 t, right? Similar for S2. So S1 t plus 1 and S2 t plus 1 completely depends on our previous time step elements. And this will be similar. U1 at t plus 1, what is it? It is P1, you win the game, P1t, actually t plus 1. Right? Exactly. Plus, you lose the game. Uh, minus, just let me check if I had the second term here. Exactly, I had it. So let's do the same stuff as we did here and see what's up, what changes. So we have b2t plus 1, p2t plus 1. We wanna choose the best response to them. What is the assumption? We should have assumption at this moment. Exactly. If s1t plus 1 plus gamma b1t 1 plus 1 is greater than s2t plus 1 plus gamma b2t plus 1, then you want to set your price as high as possible, right? And which will be Q1, and oh my god, my eye. And you wanna set your cost for sponsorship as low as possible, which is this formula exactly. Or you say, no, I lost the ranking game. You don't want to pay for the sponsorship. And you set your price as high as possible. Again. Then we can say this stays true. Just the updating rule for scores will change. Now we have best response. Let's check best response to best response. Our assumption is that firm 1 won the ranking game, so firm 1's price is Q1. Its sponsorship power is this maximum term, which is 0. Oh, we don't know because b2t plus 1, we don't know. Okay, then u2 will be, he sets his sponsorship as 0, and okay, this will be 0 because S2 is, well, we are deciding on b1t plus 1, right? And we know that s1t plus 1 plus gamma b1t plus 1 should be greater than s2t plus 1. But at the end of the day, s2t plus 1 plus gamma b2t plus 1 is less than S1 T plus 1 plus gamma B1 T plus 1. Okay. Yeah, it depends. Okay. And the other direction, when the firm 2 wins the competition, firm 1 doesn't pay for a sponsorship, doesn't buy a sponsorship, sets its price as high as possible, and checking the assumption that S1 T plus 1 is greater than S2 T plus 1. So the whole thing didn't change much. It will be the same here too. S1 T plus 1 will be alpha S1T plus gamma B1T, and S2 T plus 1 alpha T. And what do we want? We want let's have the assumption that S1 T plus 1 was greater than S2 T plus 1. Alright, so S1 T plus 1 was greater than S2 T plus 1, which means our utilities S1, the price was Q1, P2 T plus 1 was Q2. Also assume this was holding S1 T plus 1 plus S2 T plus 1 Q2 P1 minus P2, and then if this holds, or this holds, B1 B2 will be 0. Then S1 T plus 2 will be alpha S1 t plus 1 and S2 t plus 2 will be alpha S2 t plus 1. Okay, but if we look at it, we look at this green inequality, the left hand side is every time being multiplied by alpha, which means after a while won't hold for a long time. Okay, so let's go to the other direction. S1 t plus 1 is greater than S2 t plus 1, but we have this inequality the other direction, and then where is it? We have this. So this time data buyer 2, firm 2 is buying enough sponsorship to change the ranking, right? So we have P1 t plus 1 as Q1, P2 t plus 1 as Q2, B1 t plus 1 as 0, and B2 t plus 1 as epsilon plus S1 t plus 1 minus S2 t plus 1 over gamma, and this makes S1 t plus 2, fuck it, this is not good for posture, S1 t plus 1 as t plus 2 as alpha S1 t plus 1 plus gamma B1 t plus 1, which stays alpha S1 t plus 1, and S2 t plus 1 is the thing that is 2 is changing, is for S2 t plus 1 plus gamma B2 t plus 1, which will be alpha S2 t plus 1 plus gamma B2 t plus 1 will be gamma epsilon plus S1 t plus 1 minus S2 t plus 1, which ends up being alpha S1 t plus 1 plus alpha gamma epsilon. So it's just about S1 t plus 1 a bit bigger, right? but they are close. They are getting close to each other. Their difference is not much. So let's assume, so this is the situation. We have S1 and we have S2, right? If S1t is greater than S2t, right? If S1t is greater than S2t and the green inequality holds in that direction, it's big enough, it's bigger than Q2 times P1 minus P2, then both of them will be smaller. We'll get smaller with a rate of alpha, right? They are both going alpha times next time, right? And then they get small enough that that inequality doesn't hold. Let me... So this is here, and they get smaller with a geometric or exponential rate. And once for example the difference is this much, we change the inequality changes, right? And S2t plus 1 t plus 2, this S1t plus 2 will still go on this curve, will stay on the curve, right? Holds this curve. This motherfucker this time, however, buys a sponsorship. He comes here. He comes here. He comes here. This guy is here. Right? Still, their difference is not big enough. Their difference is like, where is it? Alpha, gamma, epsilon. Their difference is alpha, gamma, epsilon. So then they just play a game of switching. But they are being switched, right? But both of them at the same time they are being multiplied by alpha. So the switch difference is not huge, and they both have a, like this time this will be times alpha, which is pretty much this being alpha times. And this guy goes up, but just brings himself here. And then this guy maybe wants to come here. This guy comes here, and then they converge to one thing. Both of them converge to 0 again, and B1t and B2t converge to 0 as well. Converge, yeah, exactly. Even though they change periodically. So not a huge change, even with the memory system. Honestly, I don't think it is worth coding. The code, uh, well, the coding part is not that important anymore. Writing down the results so far is important, but never mind. The code is pretty similar to the steady state. Considering 2 time step. What about that? Considering 2 time step, I don't think it will be a huge change. Because our system, our dynamical system is a first order like system, right? So let's, instead of considering B1T, B2T, P1T, P2T, B1T plus 1, B2T plus 1, P1T plus 1, P2T plus 1, let's consider a simpler case that we say to be honest, it's not interesting, but what if we say we can decide what if players could decide. This is definitely simpler. And same thing for player 2, right? And memoryless. Even, okay, wait a second. How is S1T helping? Right? Because we also have B1T. Uh, mhm. And U1 again will be minus B1 2 plus 1, right? And let's assume S1 T plus 1, right, plus gamma B1 T plus 1 greater than S2 T plus 1. We can say the same shit. P1, make it Q1, B1, S1 T plus 1. Doesn't change much. It's just not bullshit. So fuck this. Doesn't change. It does not change much. It is not interesting, to be honest. Okay. So this shit anyway. Yeah, but it's not working. Hey. Let's go take a look at Kaggle dataset. Mm-hmm. What are the columns? Um, Oh, idea of the hotel. So that's good. So we have idea of the hotel. Am I sharing? Yeah. We have idea of the hotel because we want to know the hotel's ranking. That's true, right? And what else? Can I see it? Um, well, sign in. Sign in with my Google. Okay. That's a good point. Why should I download it? Do we have it? Fucking... Can you open this shit? I just want to see the columns, and that's it. Well, in the Excel notebook, they don't have the explanation for each column. So, um, Okay, we have the rating of the hotel, the ID of the hotel, um, column, compact, column. Okay, that's great. Search ID, date, time, site ID, um, ID of the customer. Okay, that's not important. Um, Rating of the hotel. Huh? The star rating is not known. Okay. The mean customer review score for the hotel on a scale of 5. Well, this is star rating, isn't it? Price. Oh, promotion flag. That's important. Wait, are you seeing it or not? Yes. Okay. That's an interesting thing. Promotion flag. So like, yeah, we wanna length of stay. Okay, they are all the filters they are using. So if you wanna say ranking, we need to make it for the consider the ranking for one filter searches. This is important. Search query affinity score odds. But we don't have hotels ranking. That's the problem. All right, guys. I think it's good for now. Um, Thanks for being with me. We will be back.